Hello everyone, welcome to JDK Institution. In this video, I'm gonna discuss few answers on this today's exam. Okay, without any delay, let's get started. Which of the following statement about the properties of electric charges is incorrect? Charge is conserved, charge is additive in nature, charge is quantized. Remaining is like charges attract each other. It doesn't comes under this. Electric field. We know that electric field is nothing given by E is equal to F by Q, force by charge. That is nothing but force unit is Newton, charge is Coulomb, which goes off become Coulomb per meter. And electric flux is nothing given by Newton per Coulomb, and electrostatic force is Newton. So the option is C. Okay. Without a second one, next one, third one. The shape of equipotential surface in a uniform electric field will be equidistant planes to the normal electric field. It is a property. Now, the two conducting spheres A and B of radii A and B respectively. So, radius is A and B respectively are at same potential. Potential is same. Let us consider. We need to find the charge densities A and B. Let us consider VA, that is sphere A. Potential of sphere A is equal to potential of sphere B. It can be given by K into Q1 by distance is small a, that is equal to K into Q2 by B. Now the ratio of A and B, that is Q1 by Q2, is nothing given by B by A. So answer is option A. Next one is the average thermal velocity of an electron is 0. The direction of motion of electron are randomly oriented. So when no electric current is applied, the electron moves in a random direction. Whenever you apply the electric field to a conductor, it will orient in the direction of electric field. When there is no electric current, then there is no orientation, and hence the average velocity becomes 0. Therefore, the free electrons are moves in a randomly oriented. So option is A. Sorry, option is A. Next one is the insulator, or as the temperature decreases, resistivity increases. Magnetic force is 0 as an electron moves parallel to the uniform magnetic field. That is, we know that magnetic field is minimum at 0 degree. That is, which is moving parallel, right? Next, the torque tau on the current loop of magnetic momentum M placed in a magnetic field B is nothing but, it is a direct question, tau is equal to M cross B. When the electric current is passed through a solenoid, it behaves as an bar magnet. Why? When the current is passes through a solenoid, it produces a magnetic field which is similar like a bar magnet, because the magnetic field lines inside the solenoids travels in a straight line and parallel to each other. That's why it is a acts like a bar magnet. And magnetic susceptibility is of a magnetic susceptibility of ideal diamagnetic substance is -1. Next one, the direction of induced EMF is given by uh, which rule? It is a Lenz law. Next one, Weber is a SI unit. Weber is a unit of magnetic flux. Next one is 13th one. The peak voltage of AC source is equal to how to do it? Let us consider V naught. V RMS is equal to V naught sine omega t. Sorry, V is equal to V naught sine omega t. We know that Vrms is equal to V naught by root 2. What we need is V naught. V naught is equal to root 2 into Vrms. So option is D. And next one is a transformer is used to Convert AC to DC. The conversion from AC to DC is done by rectifiers. Convert DC to AC. It doesn't comes under transformer, not an AC voltage, to obtain the desired DC voltage. For this, we have two types of transformer. One is step up and step down. Next one is arrange the electromagnetic waves in a increasing order of wavelength. Increasing order of wavelength means first one is gamma, that is 3. Okay, here is 3. Okay, gamma. After gamma, it is X-ray. After X-ray, visible ray, AML, radio wave. So option is A. Next one, 16th one is on reducing the voltage across the capacitor, capacitance remains constant. The direction of current density is dash to the direction of drift velocity of free electron in a conductor is, it is always opposite. The resistance of ideal ammeter is 0. 18th one. Dash is the net magnetic momentum per unit volume. Magnetization. Magnetization is the net magnetic moment per unit volume. Electromagnetic waves, electric and magnetic fields are perpendicular to each other. Now coming up to the 2 marks. When does the torque acting on an electric dipole in a uniform electric field is maximum at 90 degree and minimum at 0 degree. Calculate the electrostatic potential of positive charge of 10 microcoulomb placed at a point where electric potential is 2 volts. So how to do it? We know that U is equal to U is equal to QV, where Q is the charge, that is 10 into 10 to the power minus 6 into voltage is 2. It becomes 20 microcoulomb. Okay. Next one is define current sensitivity. So you have to define the current sensitivity definition and how it can be increased. It can be increased by number of turns, area of coil, magnetic field, or any one of this. You can write it out. You will get 2 marks. Mention any two properties of magnetic fields. You have to mention two properties of magnetic field lines. And state ampere circuit law. For statement 1 marks and equation 1 marks. Electrical resonance, you have to define the electrical resonance, and you have to mention the expression which comes under like this. Yeah, sorry. F naught is equal to 1 by 2 pi root LC. This is the expression for the resonant frequency. The next one is write the expression for drift velocity. Drift velocity, write the expression for displacement current and explain its term. The displacement current is written by ID is equal to epsilon naught d phi by dt. This is you have to explain the each term. You will get the 2 marks. Next one is any two applications. You can write any two applications. After that, 29th one, you have to mention 2-point charges in the absence of electric field. That is work done bringing in one positive charge and work done bringing in second positive charge. For first work done bringing the first positive charge is 0. Second one is 1 by 4 pi epsilon naught into Q1 Q2 by R. So that adding both, you will get W is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. R. That work done is nothing but potential energy U. U is equal to 1 by 4 pi epsilon naught Q1 Q2 by R. Next one is you have to write down the resistivity formula and explain the term and write the SI unit, that is ohm per meter. Next one is Kirchhoff junction rules and the loop rule. You have to give the statement for the both Kirchhoff law, and you have to mention which signifies the conservation of energy. Next one is you have to explain Biot-Savart law with equation, and you have to write down the vector form for 3 marks. And 33 question is a circular copper coil of radius 6.28. So R is given 6.284 centimeters, has a 20 ton, that is n is given and I is given. So how to calculate is, uh, we know that magnetic momentum m is nothing but nia. So you have to find out a. A is nothing but they are given circular loop. Therefore, ni into pi r square. So you know the value of ni and r square. So you have to substitute this value and get the equation. Okay, which comes under like 0.449 something ampere meter square. And next one is you have to mention the differentiate diamagnetic and paramagnetic substance. You have to minimum three differences and obtain the expression for motional EMF in a rod moving in a magnetic field. You have to derive expression, that is E is equal to VBL. This on the expression. L can be varied because whatever the L or X, whatever you have taken, that comes here. Okay. Then you have to mention three transformer loss like eddy current, so flux leakage or hysteresis, something like that. You have to mention three losses. Next one is derive an expression. You have to derive the expression. Diagram contain 1 marks and the remaining derivations, all everything should be written properly. That is a long solenoid, like carrying a wire conductor. Next one is two capacitor connected in series. So 1 by C, that is comes under like 1 by C is equal to 1 by C1 plus 1 by C2. You have to do that derivation. After that you have to mention two equipotential properties. After that, derive an expression for effective EMF and effective internal resistance of two different cells. So you have to do a cell derivation which is connected in parallel. Okay. Arrive at expression for force between parallel plate conductors. You have already learnt like a current carrying wire, the force experienced by the like this derivation should be done for the 40th question. And after that you have to define the ampere. What do you mean by ampere? 41st question, you have to state and explain Lenz's law in electromagnetic induction. It contains 3 marks. And for B, AC generator 1 and its principle 1 marks. Total 5. Next one, 42th question. Here there are two charges placed. Let us consider these two charges like this one A, A, B, C, which is separated by a distance 10 centimeters all the way, uh, are placed at vertices B. B is plus 5 coulomb and C is negative 10 coulomb. The electric force is experienced by this point A is in this direction due to EC and in this direction due to EB, and the resultant is in this direction. You have to find out. We know that the formula is E is equal to 1 by 4 pi epsilon naught q by r square, or q1 q2 by r square. You have to find out q by r square. You will find the value for E1, that is for plus 5 how much, and E2 for minus 10 After finding E1 and E2, you have to find the resultant, that is E is equal to square root of E1 square plus E2 square, and this will comes under average of 7.79 into pico Newton per coulomb. Okay. After finding a peak of this is the required. After finding that the direction is alpha is 30 degree with E2. Okay. Next one is 43th question. 43, in a parallel plate capacitor of each plate is 5 meter. So here parallel plate capacitor radius r r is given 5 centimeter, separated by a distance d is given, and you have to find out the energy. So first we need to find this C, that is equal to C is equal to epsilon naught A by D. You know the value of epsilon naught, and the area they didn't given. So epsilon radius is given. So pi r square, because it is a circular parallel plate. Okay. So pi r square by D. You have to find out the value of C. You know the value of epsilon naught pi r is given, d is given, so you will get value of 34.75 picofarad something. After finding that, you have to find the energy. U is equal to half cv square. You know the value of c. V is given 200 volts. So calculating this, you will get around 69.5 into 10 to the power minus 8 joule. Okay. Now coming up to the 44th question. A copper wire has a resistance of 10 ohms and area of cross section 1 millimeter square and potential difference 10 volts. So here the resistance R is given, that is 10 ohms, and area of cross section is given 1 millimeter square, and V is given, that is 10 volts, and small letter n, that is number of charge density is given. We know that I is equal to NEA VD. Here we know the A, E and N. We don't know the I. But they have given R and V. So we know that V is equal to IR. I is equal to V by R. That is equal to 10 by 10 is equal to 1 ampere. So substituting these values, VD is equal to I divided by NEA. Now you can find the drift velocity. Okay. You will get around 7 point. You will get around 7 point. ಎಷ್ಟು ಬರುತ್ತೆ 7.812 into 10 to the power minus 5 meter per second. Next one is the resistance or the resistor of 100 ohm pure inductor L is equal to 0.5 Henry, and the capacitor in series in a circuit containing AC source of 200 volt 50 hertz. A current head of voltage is 30 degree. Find the value of capacitance. Here R is given 100 ohms, inductance L is given 0.5, and V is given 20, and frequency is given 50 hertz, and theta or phi is given 30 degree. Now what you need to find is XL, because you know the inductance XL is equal to 2 pi f into L. You know the value 50 hertz, L is given, you will get XL. Now what you need to find out is XC. We know that tan phi is equal to XC minus XL divided by R. R is given. So theta tan phi is given. You will find the value of tan phi by applying 30. And XL is already calculated. R you know. And you need to find out is XC. You will get the final answer. This is the answers key for your today's exam. Thank you.